Hello everyone and welcome to Mind for Physics. This video is about vectors again. I recorded two videos that are conceptual about vectors. This one, the plan for this lecture. First, I'm going to show you vector notation that's used a lot in physics. And second, we're going to solve one problem together. So I can give you a vector in this form. I can tell you that vector A is 2 meters in length and it is pointing 30 degrees north of east. I've given you magnitude, 2 meters, and direction with this angle. So that's full information, all that you need to know about a vector. So this would be the vector. It will be 2 meters in length and this would be the angle that it will make with respect to x. Okay, this is up from positive x direction, so north of east. East is positive x direction. By the way, notice that the length of this vector, its x component will not be 2 meters, and its y component will not be 2 meters either. X component will be 1.7 meters for this specific vector, and y component will be 1 meters. So you'll see why exactly in the next lecture, but just notice that for now. So this is not the way that you will be presented with a vector usually. Usually you're not going to be given a length and the angle. Usually you're going to be given a vector in this form, unit vector notation, using I hat, j hat, and k hat for 3 dimensions. So I hat and j hat in 2 dimensions. So I hat, j hat, and k hat somehow is a little bit scary for students, and I remember it was for me as well, but it's actually a very simple concept. These are unit vectors that are there to not complicate your life, and they're not trying to change magnitude or do anything with the magnitude of a vector at all. Unit vectors are there to simply show you direction. So unit vector, the name is because their length is 1 unit, so that's why they don't change the magnitude of any vector. So any number multiplied by number 1 is the same number, right? So if you multiply 5 by 1, it's 5. If you multiply 6 by 1, it's 6. So that's totally fair. You can multiply any number by 1 and you're not changing its magnitude. And these unit vectors have the length of, always are going to have length of 1 unit. So they will want to do nothing with the magnitude. They will always be there to show you direction. And they're actually there for that purpose alone. Okay? So when you're given a one-dimensional vector, vector A equals 15 I hat. That means that vector A is across x-axis. That's because it's one-dimensional. One-dimensional vectors are across a straight line. It could also be across y-axis. In that case, it would be 15 j hat. So one-dimensional vector, the angle that they make with the x-axis is 0. They're going across, right, parallel. So you can also draw this little unit vector here. As you can see, its length is 1. It's just there to show you direction. Okay, two-dimensional vector would be this one right here. Okay, it will have some non-zero angle that it will make with respect to x and with respect to y. That's that's why it is two-dimensional. And its x component is 15, its y component is 8, because j hat is telling you that across this direction, across the vertical direction, its magnitude is 8. So you draw it like this. Notice that you're actually not given vector B. All you're given using this vector notation is vector B's components, x component and y component, using I hat and j hat respectively. So you can actually build from that and determine the magnitude and direction of vector B, but you're not given vector B per se. You're not given its magnitude. That's what you're going to learn to calculate in this lecture. Okay, this would be a 3-dimensional vector. This pink one is 3-dimensional vector. It's never easy to show 3-dimensional anything on a two-dimensional screen or a board, right? But I'm gonna try to do my best using these dashed lines. Usually they draw a three-dimensional shape in there, like a cube or something, to help your eyes to appreciate that this is a three-dimensional vector here, because it's kind of hard to perceive this. Okay, so let's jump into solving a problem using this notation. Okay, so you're presented with vector A that has a length of 3.0 across I direction, across X direction, and 5.0 across Y direction. Expressed it with J hat. You are asked to calculate its magnitude alone. So first thing that you do is you draw its X component and its Y component, like so. Now we can zoom in to first quadrant because we don't need second, third, or fourth, because both of the components of this A vector are in first quadrant. So obviously the vector itself is going to be in the first quadrant, right? That makes sense. So this is going to be the vector. But even though I can draw it right away, I don't know its length. I don't know its magnitude. And I also don't know its angle, but that we're going to do in next lecture. So here we're going to find its magnitude, and the way that you can do that is using either of these exactly same triangles, whichever you prefer. I usually work with the bottom one. So what you're going to need to do for that is transfer this vector over. You can shift vectors parallel without changing its magnitude or direction. If you did that, you would be changing the vector itself. That's not allowed. So you're going to parallel shift vectors, which is allowed. Therefore, it will have exactly the same length, so it will be 5 as well. Right now, you're going to calculate its magnitude, which is basically the length of the hypotenuse here. And you know how to calculate the hypotenuse of a triangle using Pythagoras theorem. You square both sides, you add them, you take the square root, and there you have it. That's the length of the actual vector A, which was not given to you, which you had to build from these building blocks that you were given. These components are building blocks of an actual vector A. Of course, magnitude is not enough information, and this unit vector notation gives you enough information to find magnitude as well as angle. We're going to find angle in the next video. That's all. Thank you so much for watching, and have a great week. Bye.